natural dye for industrial clothing dyeing.
The textile industry significantly contributes to water pollution due to its use of synthetic dyes. These chemicals are hard to degrade and contaminate natural water sources, using natural pigments from vegetables as bed. Turmeric and spinach offer a sustainable, biodegradable, and alternative. This project explores natural dye prototype as an eco-friendly solution to reduce environmental impact.
As context of the problem, we have that the textile industry is responsible of the 20% of water pollution. This because the use of colorants that are really toxic and difficult to degrade that end in rivers, lakes, and aquifers.
The solution proposal. The proposed solution considers taking advantage of the natural pigment present in products such as beet, turmeric, red onion, spinach, and other fruits and vegetables capable of generating intense and stable color. Then, the dyes. These pigments are extracted using simple methods with low environmental impact, which allow us to obtain biodegradable and safe, much less polluting dyes than industrial.
And also continue with the justification of on the reality of our proposal. Based on the above, we can enforce our posture with the article of the European Parliament that is named The Impact of Textile Production and Waste on the Environment. In this article, it said that a single load of polyester clothing can release 700,000 microplast fibers that can enter in the food chain. All the waste that is industrial waste go into some waterways like rivers. This water can reaches in some communities, causing damage and negative impact in the health.
Our prototype is a natural dye made from pigment-rich vegetables like beet, carrot, and black beans. It avoids synthetic chemicals, making it safe for food, cosmetic, and textile use. It's also sustainable and eco-friendly because it relies on renewable, biodegradable ingredients. Our dye is packed in 100mm glass bottles.
Table with the variables for our prototype. We have 4 variables: environmental impact, water consumption, color fastness, and production and cost of safety. Environmental impact refers to how much the dye pollutes water or affects adequate life after disposal. Material. Our prototype is made from biodegradable plant-based materials, which is better for the environment, while the industrial dyes contain toxic chemicals and heavy metals that contaminates rivers and harm ecosystems. For water consumption, it is the amount of water required during the dyeing process. Our prototype requires less water overall since it doesn't need as many rinses or chemical treatments, while industrial dyes need a high water usage due to multiple rinsing and fixing steps with chemical agents. For the color fastness, it is the ability of the dye to resist falling from washing. Our prototype has a moderate color fastness since it is made with more homemade materials, while industrial dye have a higher color fastness since it is made of synthetic chemicals that ensures long-lasting vibrant colors. Lastly, the production cost and safety is the economic cost and risk level of the materials we need for its production. Our natural dye prototype has a low cost, safe to handle, and non-toxic materials, while industrial dyes are more expensive, more dangerous against the health of the humans.
We continue with the prototype operation. To describe our prototype, we can say that it's a natural dye made from natural products, such as beet to color red and spinach from color green, and like that with other colors. With this prototype, we can say that our objective is to replace the artificial dyes that the textile industries uses daily, making a lot of damage in the natural environment and in our health. With these dyes, we replace all that negative impacts in the world.
So, as expected results, we hope that natural dyes can perform the same functions as industrial ones to reduce the impact in the environment and reduce the water pollution.
Which parts of the STEM were used to make our prototype? S, which stands for science, helped us identify which natural pigments work, how they bind to fabrics, and how they reduce water pollution compared to industrial dyes. T, which stands for technology, provides the tools and methods for extracting, filtering, heating, and testing the natural dye to ensure consistent results. E, which stands for engineering,
References.
designs the prototype, the extraction setup, the dyeing process, and ways to use less water and avoid toxic chemicals. M, which stands for math, allows us to measure quantities, compare results, calculate concentrations, and evaluate the efficiency of the dye.